Hello scholars, welcome back to the channel. What we're going to be doing today is substitution. So remember, I'm always telling you, when you start a new topic and you hear the name of the topic, it's a good idea to see if you can get the definition of the word as it is generally used, and that will give you a good start in understanding what the topic is about. So this word substitution, what does it mean? So the definition I have on the board: to substitute means to insert one thing in place of something else. In algebra, substitution involves replacing a variable with a given numerical value. So to substitute is to take one thing and put it in the place of another thing. And in algebra, it usually means you're given some variables, letters or symbols, and you are told the value of that variable or symbol, and you're asked to substitute, to put that numerical value in the place of the variable in the expression or in the equation, right? Usually in an expression. And then you're going to simplify the expression to get a final numerical value. That's it. So remember, when you're at school and you have your teacher who would normally teach you a particular subject, and something happens and that teacher can't get to come that day or that week or that term, and you get a substitute teacher. So this teacher is not your permanent teacher, but the teacher is coming in to play the role of your usual teacher. She's substituting, or he's substituting. Or if you're cooking, you're in the kitchen cooking, and you normally would use milk, and you don't have any milk, and you're saying, what can I use instead of the milk? What can I substitute for the milk? Or if you normally use butter and you don't have any butter, or you've decided not to use butter anymore, what can you use instead of the butter? What can you use to replace the butter? So you might use margarine, you might use coconut oil, you might use anything that can do the same thing that the butter would have done. Or for the milk, you might use almond milk, you might use rice milk, you might use soy milk, right? Anything that can replace the milk and do what the milk would have done. So that's what we're doing here. We're given numerical values for the variables. So we're told, let's say x is 5. Let's say y is -4, and let's say a is 0. Substitute those values wherever you see x. You're going to put a bracket and put 5, because 2x means 2 times x. Wherever you see the coefficient and the variable, that means there's a multiplication operation going on. So if we're substituting the value, we can't just put 2 5. That will be 25, and that's going to confuse you and whoever is looking at your work. It's not 25. So we need to put a bracket and put the 5 there to show, the bracket is showing you we're multiplying the 2 times the 5. Alright? So let's go. So wherever we see x, we're going to put a 5. Wherever we see y, we're going to put -4. Wherever we see a, we're going to put 0. So it's 2, open the bracket and put 5. -3 times 0, and we could put plus -4. We don't really have to, we can just put, I'm going to leave it for now, but normally if there's no coefficient beside the variable, you can just put the value of the variable, and in this case it's a -4, so we did not have to write the plus. So 2 5 is 10. 3 times 0, that's 0, -4. So the final answer is 6. Okay? So all of this expression, when we substitute the values, we end up with 6. Alright, so let's go now. It's negative 6 times negative 4 plus 0 is 0 minus 10 times 5. Negative 6 times negative 4 is a positive 24 plus 0 minus 50. Alright, so 24 minus 50, I believe that's negative 26. 2 times negative 4 to the third power minus 5 to the third power. Alright, so this is important here. We bracketed the 5 because we are raising the x to the third power. We're not raising negative x, we're raising x to the third power. So we put back our minus sign and we're going to raise the 5 to the third power. If this had been bracketed, if the negative x had been bracketed, that would have been different, right? It would have been, then we would raise it, the whole thing, the whole negative 5 to the third power. So negative 4 to the third power. Remember, when you're raising a negative number to a power that's an odd power, whether 3, 5, 7, if it's odd, you're going to end up back with a negative number because the first two would give a positive and then the odd one would bring it back to negative. So this is 2 times negative 4 times negative 4 times negative 4. So negative 4 times negative 4 is a positive 16. And then that positive 16 times a negative 4 will give a negative 64. And 5 to the third power is 125. Alright, so 2 times negative 64 is negative 128 minus 125. So 8 and 5, 13, 5. So that's negative 253. Please check with me as I go along. Make sure that I'm correct. Alright, so we're raising x to the negative 1 power. X is 5. So 5 to the power of negative 1 plus 7 times 0 times negative 4. Now we know once we're multiplying and there's a 0 involved in the multiplication, all of that will be 0. So we're not even going to bother with this here. This is all 0. The 5 to the negative 1, when you raise a number to a negative power, is 1 over that number raised to the power. So it's 1 over 5 to the first power, which is 1/5. So raising a number to a negative power means the inverse, 1 over the number raised to that power. We're raising 5 to the first power, that's 5. Alright, so we're given a new set of values. We're told let A be negative 1, let B be 1, let C be a half. So it's 8 times a half minus negative 1 plus 7 times 1. 8 times a half, half of 8 is 4. Negative times negative 1, that's a positive 1. 7 times 1 is 7. 4 plus 1, 5, and 7, that's 12. 10 to the power of B. B is 1. 10 to the power of 1 minus negative 1 plus a half squared. 10 to the power of 1 is 10. Any number raised to the power of 1 is just that same number. Negative times negative 1 is positive 1. Half times a half is a quarter. So a half squared is a quarter. So we have 11 plus a quarter. So that's 11 and a quarter. Alright, so negative 5, C is a half. Negative 5 times a half times 1 plus negative 1. So we can just put that. Alright, we know that a half times 1 is a half. And negative 5 times a half is negative 5 halves minus 1. So that's negative 2.5 minus 1, that's negative 3.5. Okay? Negative 2.5 minus 1, negative 3.5. Okay, so here we have 6/8 times C. C is a half. Minus b to the 7th. So b is 1 to the 7th power. 1 to any power is the same 1. 1 times 1 times 1 times 1. 1 to the 7th power is 1. A half of 6/8 would be 6 over 16, which cancels down to 3/8 minus 1. So this would actually give us negative 5/8. Okay, so 3/8 is less than 1. We're taking out 8/8, changing the 1 to 8/8. 3/8 minus 8/8, so that's negative 5/8. Alright, so now we're given another set of values, because remember, in substitution, they can change up the values of the variables, the numerical values of the variables. So they're just saying, let's pretend that this letter is equal to that number. And they can switch it up again and say, okay, new game, let's pretend that it's this now. What some students think when they're given the first batch of numbers and they say x is that, y is that, b is that, they think that it should always be equal to that numerical value. No, no, no. In substitution, it's like a game, and every time you finish playing that round, a new set of values are given for the letters, for the variables. So you have to look out to see what are the new values that we're working with this time. Because if you bring over the old values from the last batch, your answers are going to be wrong because it's a new set of values. So they're saying, right now, we want W, the variable W, to be equal to 10. We want P to be negative 11. And we want Q to be 3/4. So let's substitute those values. So where Q is, we're going to put 3/4. Where W is, we're going to put 10. And where P is, we're going to put negative 11. When we multiply 8 by 3/4, the 4 cancels the 8, and 2 3s are 6. 6 times negative 10, negative 60. Negative times, the negative is working on this operation here. It's a bracket. So we're multiplying two negatives, we get a positive. So it's 6 minus 60, which is negative 54. Negative 54 plus 11. So that would be negative 43. Right? Negative 54 plus 11, that's negative 43. Alright, so let us substitute now. Where W is, we're putting 10 squared plus, well, it's 11, negative 11, and Q is 3/4. So we're going to raise the 10 to the second power and then make that answer negative. If they had bracketed the negative W, then we'd raise the whole thing to the second power, but they didn't. So 10 to the second power is 100, so negative 100 minus 33 over 4. 33 over 4, that's 8.25. So it's negative 108 and a quarter. Alright, so now we have 9 times 10 minus 12 times 3/4. 9 tens are 90. 4 into 12 goes 3 times. 3 3s are 9. 9, that's 81. Q to the third power. So Q is 3/4. 3/4 raised to the third power. So 3/4 times 3/4 times 3/4. Plus 1 over 121 times 11. The 11 is going to cancel into this 11 times, so that's 1 over 11. 3/4 times 3/4, that's 9/16 times 3/4. So that's 9/16 times 3/4 again. That's 27 over 64. 27 over 64 plus 1 over 11. Alright, so we'd have to simplify that, and we could work the fraction. I don't think I'll have enough time. So let's go to these over here. So we're substituting. Let x be 4, y be 9, and n negative 6. Right? So wherever x is, we're going to put 4. Where y is, we're going to put 9, and n, we're going to put negative 6. So 6 times 4 plus 5 times 9 minus negative 6 over 3 times 4 squared plus 2 times 9. 6 4s 24, 5 9s 45, plus 6. 4 4 is 16 times 3, that's 48. 2 9s 18. So 24 plus 48, that's 69. Plus 6, so that's 78. Sorry, 69 plus 6, 75. And 48 plus 8, 8 and 8, 16. 66. 66 into 75 goes 1 time, remainder 9 over 66, which can be reduced. 3 into 9, 3, and 3 to 66, 22. So that's 3 over 22. Alright, so let's do the other one. We have negative 4 times n. So negative 4 times negative 6 plus 2 times 4 cubed over 10 times 4 times 9. Okay. So negative 4 times negative 6 is 24. 4 cubed is 64 times 2. So that's 128 over 4 9s 36 times 10 is 360. 128 plus 24, 8 and 4, 12, 5 over 360. And this can be reduced by 4. Can it? 4 into 15, 3, 4 into 32, 8, and 4 into 36, 9. So that's 19 over 45. Alright, 19 over 45. Let's see how much time I have left. I think I have 2 minutes left. Alright, so let's work as far as we can go. So negative x squared, negative 4 squared times 9 over 5 times 4 times negative 6. So 4 squared, that's 16 times 9. 9, 6 is 54. 9 minus 9 and 5, 40. So that's 144. Negative 144. And 5 fours 20 times negative 6, that's negative 120. Using 4 to reduce those, so 4 into that. 4 into 14. 3, 6. So the final answer is 9, 10. Alright, so here we have 3/4 of negative 6 minus a half times 4 squared. So negative 18 over 4 cancels to negative 9 over 2. And 4, 4, 16, half of 16 is 8, that's negative 8. 9 over 2, that's negative 4 and a half minus 8. So the final answer here, negative 12 and a half. And finally, 3 over 9 times 9 plus 4 minus negative 6 to the third power. Alright, so negative 6 times negative 6, that's positive 36, times negative 6. 6 6 is 18, 6 6 is 36, 6 3 is 18, and 3 21.